Dear students, in today's lecture, let's make an attempt to know about integrated management of mulberry diseases. Introduction. Mulberry, the sole source of food for the silkworm Bombyx mori, contributes 38% towards harvesting successful cocoon crop. The quality and quantity of silk produced by silkworm depends on the quality and yield of mulberry leaf. The sericulturist requirement of nutritionally rich and high yield of mulberry leaves has always been threatened by diseases, pests, natural calamities and poor cultivation practices. The diseases are the main constraints in mulberry leaf production and are caused either by pathogens or non-pathogens. Among the pathogens, a number of fungi, bacteria, nematodes, mycoplasma and viruses have been known to cause economically significant losses world over. Further, biochemically, diseased mulberry leaves are poor in proteins, sugars and moisture. Feeding such leaves to silkworms has been found to adversely affect the growth and development of larvae, resulting in poor yield of cocoons. The common diseases observed on mulberry are: number 1, foliar diseases, Cercospora leaf spot, powdery mildew, leaf rust, bacterial leaf blight or spot, mulberry yellow net vein and mulberry mosaic. Second one, stem diseases, stem canker, sclerotial collar rot, Phoma collar rot, stem blight and bud blight. Third one, root diseases, root knot and root rot. Among the diseases of mulberry, leaf spot, powdery mildew, leaf rust, stem canker, root knot and root rot were known to cause considerable damage. With the introduction of mulberry into non-traditional sericultural areas and intensification of its cultivation, frequent occurrence and severity of diseases have been noticed. Hence, a close watch, timely control measures and regular monitoring are very essential to manage the problems posed by diseases to enhance leaf yield and quality. Management of diseases by adopting individual method is either less effective or short-term in nature. Of late, integrated management of diseases of mulberry is gaining momentum in recent years in managing diseases on long-term basis. Integrated disease management, that is IDM, is a system or method which utilizes all suitable disease suppression techniques and methods in as much complementary and compatible manner as possible in order to keep or maintain the disease intensity below those causing economic injury. By integrating several tactics, reliance is not placed on any single one. Employing an IDM package for disease management has gained immense importance as it is realized as a holistic approach to a disease problem, unlike the individual disease management strategies, including the chemical ones, which are either less effective in obviating disease problem or indiscriminate in their effects. Moreover, the IDM avoids the possibilities of the disease developing resistance or resurgence of the diseases. One of the interesting features of IDM is that it promotes disease resistance in plants, and this method saves cost of chemicals and also proving to be an environment friendly disease suppression strategy. Finally, IDM renders the whole disease suppression operation an economic one. Second one, integrated management of foliar diseases. Cercospora leaf spot. The leaf spot disease is caused by fungal pathogen Cercospora moricola, that is authority is Kuke, and causes 16% crop loss. This disease can be observed during southwest monsoon season from June to October. Management strategies. Cultural methods. The infected leaves should be collected and burnt prior to receipt of rain to reduce availability of the inoculum in the garden for further spread. Field sanitation includes destroying all the diseased plant pots from the field to reduce the inoculum of disease. The weeds in the mulberry garden affect the healthy growth of mulberry by competing with it for space, light, moisture, nutrients, etc., and hence they can be controlled. Application of more farm-made manure, that is FOM, will help the growth of beneficial microorganisms in the soil, which in turn will help to suppress the soil pathogens. The diseased mulberry leaves should be harvested for feeding the silkworm. Appropriate agronomical practices should be followed to minimize the disease incidence and to harvest leaves of high quality. Use of disease-tolerant varieties like Bilidevalaya and Kalia Kuttai are good sources of tolerance for leaf spot disease. Biological methods. Biological methods involve the use of other living organisms such as pathogenic protozoans, fungi, bacteria, and viruses to check the growth, development, and reproduction of pathogens. The fungus, Cercospora moricola, can be controlled by spraying the antagonistic fungi Trichoderma hergianum and Trichoderma viridae. This is safest method and ensures healthy growth of mulberry in a disease results in production of more quantities of quality leaf. Chemical methods. Spray of 0.2% carbendazim or benomyl, that is 2 gram of chemical per liter of water twice at 15 days interval by following a safety period of 15 days. Different fungicides and antibiotics are used for the control of leaf spot disease, thus avoiding of leaf loss and its quality. Powdery mildew. Powdery mildew, Phylactenia corylea, authority pers, karst, is the most common and widespread disease of mulberry. Its occurrence is reported from almost all the mulberry growing areas in both tropical and temperate parts of the world. It is more prevalent in hilly areas than the plains. It is more common during rainy and winter seasons and is favored by cool, shady, and moist environment. Its intensity reaches maximum during December to February in South Indian conditions. It reduces the leaf yield up to 20%, besides deteriorating the leaf quality. Management strategies. Cultural methods. Adopting wider spacing facilitate adequate aeration and penetration of sunlight to reduce disease incidence. Removal of weak branches and weeds checks the humidity buildup under the plant canopy, thereby reducing the severity of disease. Field sanitation includes destruction of diseased leaves and plant pots, eradication of disease-affected plants. Growing of disease-free plants is helpful for controlling the disease. Use of disease-tolerant varieties. Biological methods. The powdery mildew disease can be controlled by Trichoderma hergianum. Yellow ladybird beetle is used to control the powdery mildew disease. Chemical methods. Chemical control of mildew becomes necessary in hilly areas and regions receiving heavy rainfall. Fungicidal spray of 0.2% carbendazim or dinocap, that is 2 gram per milliliter of chemical in 1 liter of water, should be applied. Benomyl or captan, that is 1 to 2 gram of chemical in 1 liter of water, can also be sprayed as soon as symptoms appear on plants, which may be repeated after 15 days if necessary. Leaves can be fed to worms after 15 days if carbendazim is sprayed and 20 days if dinocap is sprayed. Leaf rust. Leaf rust, Peridospora mori, authority Berkeley, is a fungal disease and the incidence is common during winter months of November to January. The loss in yield of mulberry due to disease is about 5%. Management strategies. Cultural methods. Timely utilization of leaves during winter months is most essential to prevent inoculum buildup in the garden. Wider spacing in plantation has been found to reduce the disease incidence. Providing proper aeration and light to leaves of mulberry. Field sanitation and eradication of affected plant pots. Removal of weeds from mulberry garden. Use of disease-free planting material to avoid incidents. Use of trap crops or toxic plants as one of the most effective methods to control the leaf rust disease. The variety like Cotanio is good source of disease tolerance for leaf rust disease. Use of tolerant varieties as a breeding material to evolve commercially cultivable disease tolerant mulberry varieties. Biological methods. Utilization of the predaceous and parasitic insects, pathogenic protozoans, fungi, bacteria or virus to check the growth, development and reproduction of the pathogens. This is one of the most safe, cheapest and easy methods to control mulberry diseases. Chemical methods. Chemical control using foliar spray of 0.2% carbendazim or chlorothalonil, that is 2 gram of chemical per liter of water, can reduce the disease severity and the safety period of 15 days to be followed. Spraying of fungicides like dinocap at 0.2% concentration helps to control the disease and leaves can be used for rearing after a safety period of 7 days. When this disease has spread widely in a mulberry plantation, Borax mixture should be sprayed to all the mulberry plants. Bacterial leaf spot. Bacterial leaf spot is caused by Pseudomonas mori, authority Bayer and Lambert Stevens. This disease is caused by bacteria and occurs in mulberry growing areas during June to December. Occasionally it may cause 1 to 2% loss in yield. Management strategies. Cultural methods. Infected leaves should be removed and burned to reduce the inoculum load in the garden. Removal of weeds from mulberry garden. Planting of disease-free saplings or cuttings. Biological methods. Biological methods includes use of living organism to kill the other living organism. Use of disease-resistant varieties help for control of the bacterial leaf spot disease. Use of antagonistic bacteria like Pseudomonas multifila, Corynebacterium species. Chemical methods. Use of 100 ppm, that is parts per million, streptocycline solution, that is 1 gram of chemical in 10 liters of water. The foliar spray twice at 4 days interval has been found to be effective. Residual toxicity to silkworm is absent. Mosaic disease. It is caused by mosaic virus and reported from almost all the nursery growing countries. The intensity of the disease and the loss in crop yield vary considerably depending upon the variety and climatic conditions. Management strategies. Cultural methods. Uprooting and burning of diseased plants. Elimination of insect vectors as infection may be mediated by some insects. Infected twigs must be cut and burnt as soon as found. Change of pruning from low cutting to medium cut alleviates the symptoms as pruning may have some connection with disease. Biological methods. Use of antagonistic bacteria like Pseudomonas multifila to reduce the incidence of mosaic disease in mulberry. Chemical methods. Elimination of insect vectors by spraying chemicals help in the control of the disease. Spraying of thiouracil solution, that is 100 parts per million, on affected plants twice before summer pruning causes the viroid multiplication, result in increase of leaf yield. Third one, integrated management of stem diseases. Stem canker. This is a fungal disease caused by Lesiodiplodio theobrome, authority PAT, commonly occurs in mulberry garden. As mulberry is propagated mainly through stem cuttings, the cut ends of the cuttings provide main portal for the entry of disease. Management strategies. The pathogen is soil-borne and spreads through irrigation, farm activities, insects and wind. Therefore, effective management of stem canker can be achieved through integrated management methods. Cultural methods. Roguing. This method involves removal and burning of the infected cuttings and saplings in nurseries. Field sanitation. Field sanitation is essential, especially in the control of Lesiodiplodio theobrome, which survives in the soil and on host debris. Destruction of crop debris by burning reduces inoculum buildup. Land use. Rising saplings repeatedly in the same site should be avoided, as it helps in inoculum buildup in the soil, making it sick. Such sick soil supports a very high incidence of disease and mortality of cuttings. Planting season. Planting during winter months should be avoided, as cold weather delays normal sprouting, thereby predisposing the cuttings to infection. Proper pruning. Damaging the bark or buds while pruning should be avoided to prevent entry of pathogens. Biological methods. Nursery guard. A bioformulation of Trichoderma pseudoconingi can be used for long-term protection, better survivability and growth of saplings. Mix 1 kg of nursery gourd with 60 kg of finely powdered, well decomposed farm-made manure or neem cake. Moisten mixture to a maximum of 30%. Store it under shade in the form of a heap and cover with a wet gunny cloth. This enhances the multiplication of biocontrol agent in the mixture. Broadcast the mixture at the rate of 2 kg per meter square over the well prepared nursery beds and thoroughly mix with soil by light digging. Apply the mixture only to the planting area in nursery beds. Chemical methods. Pre-treatment of cuttings. The cuttings should be dipped in 0.2% carbendazim solution, that is 2 g of chemical in 1 liter of water for 30 minutes prior to planting, followed by a spray after 15 days of planting. Protecting established plants. Soon after pruning, the cut surface of the stems should be dressed with a spray or smear of 0.2% Captan or carbendazim solution. The treatment forms a toxic barrier on the wound surface, preventing the entry of pathogenic inoculum. Soil disinfection. This method is suitable for the treatment of sick soils in nursery beds. Carbendazim or Captan at the rate of 8 kg per acre should be broadcasted after loosening the soil, followed by irrigation. After 10 to 12 days, well decomposed farm-made manure should be applied and thoroughly mixed with soil for planting the cuttings. Fourth one, integrated management of root diseases. Root knot. Root knot caused by Melodagina incognita, authority cophoid and white chitwood, is one of the major mulberry diseases. It is a nematode disease. It can occur any time of the year, mainly in sandy soils, and estimated yield loss due to this disease is 15 to 30%. Mulberry being perennial, frequent uprooting of infected plants for fresh planting is not an economically viable proposition. It is also not advisable to depend on a single method to control the nematodes, but to carefully integrate a combination of several practices, all of which will help to reduce nematode population. Management strategies, cultural methods. Nematode-free saplings should be used for planting. This is an effective method of limiting the spread of infection. A number of weeds harbor the nematodes and such weeds should be removed. Nematode damage can be minimized to some extent by providing adequate nutrition, moisture and protecting the crop from adverse condition of drought. Heavily infested soils should be deflowed to expose the nematodes and their eggs hidden in deeper layers of soils. Keeping the land free of vegetation during summer kills the nematodes due to desiccation by solar energy. Intercultivation with nematicidal plants such as marigold, that is Tagetes erectus, sesame, Sesamum orientale, etc. are known to reduce the nematode population. An economical and satisfactorily effective approach to the control of root knot disease is through organic soil amendments and oil cakes of neem, pangamia, castor and groundnut can be applied at the rate of 4 tons per hectare in 4 equal split doses for effective reduction of disease. Biological methods. Biological method involves the use of other living organism to kill the nematode population. The nematodes can be controlled by using the bacteria, Pasturia penetrans and fungus Pecilomyces tiliacinus. Chemical methods. Chemical method of nematode management requires a comparatively large investment. However, in sick or heavily infected soils, chemical treatment becomes necessary as it gives quick results. Fumigants. Fumigants are economical to use in nurseries for raising disease-free saplings. DD, that is 1,2-dichloropropane, 1,3-dichloropropane, methyl bromide, bromomethane and EDB 1,2-dibromoethane can be used. These chemicals should be handled very carefully and injected into soil under plastic seal. DBCF or Nemagon 1,2-dibromo-3-chloropropane applied as a soil drench along with irrigation water. Fumigants are injected into soil at a depth of 15 cm or more spaced at 30 cm intervals. After removing the plastic seal, 4 to 6 days should be allowed before taking up planting, usually supplemented by tillage. Granular nematicides. These are applied to soil around plants or rows. They are systemic in action. Carbofuran and Alticarb are commonly used nematicides. These are effective in reducing nematode population. Carbofuran 8 kg per hectare and Alticarb 4 kg per hectare in 4 equal split doses can be applied either in furrows or broadcasted to the soil after light harrowing followed by irrigation. Leaves can be fed to silkworms after 45 days from the date of application under irrigated condition. Root rot. Root rot disease of mulberry is perhaps the only killer known to sericulturists. The disease has become more alarming because of its epidemic nature and potentiality to completely kill the plants. The disease appears in all types of soil and climate throughout the year. Various types of root rot are found in mulberry such as violet, white, armillaria, bacterial and dry root rots. Among them, the dry root rot is found in India. Root rot, that is Fusarium solani, authority marked sac, causes sudden leaf withering and death of plants due to decaying of root bark and cortex. This is a fungal disease. Due to this disease, about 15% loss in yield was observed. Management strategies, cultural methods, field sanitation, destruction of infected roots, stubbles, etc., eradication of affected plant pots, removal of weeds and timely pruning. The bits of mulberry and other plants are made into small bundles and buried in the ground. According to Wakabe, in the year 1967, if the disease is left unchecked. The quantity of diseased stumps increase by 9 times in 3 years, 36 times in 6 years, and 100 times in 10 years. The diseased seedlings should not be used for planting. Biological methods. A biofungicide, Raksha, containing Trichoderma argyrianum, has proved to be effective and is under large-scale field trial. This biofungicide is very effective especially for root rot disease. Preparation of mixture of Raksha. Mix 1 kg Raksha with 50 kg of FOM, neem cake sufficient for 1000 plants. Keep under shade for a week covered with a wet gunny cloth to enhance the multiplication of Trichoderma argyrianum. Trichoderma argyrianum has been developed by Central Sericultural Research and Training Institute, Mysore, for management of root rot disease. Chemical methods. Chemical methods are very effective and many number of fungicides are used for controlling the disease. 1% Borax mixture solution or with 0.2% Bavistine, that is carbendazim, 50% vegetable powder solution is more effective. Apply a soil disinfection. 20% pentachloronitrobenzene, that is PCNB, granules should be applied. After disinfection, the seedlings should be immersed in hot water to destroy fungi. Fumigant chloropicrin is effective. The optimum temperature for fumigation is around 20 degrees Celsius. Dipping the root of saplings in 0.2% carbendazim solution for half an hour and planting in pits dusted with 5 gram mancozeb. The study provides a detailed account of management of mulberry diseases through integrated approach to reduce or minimize the loss caused by various diseases in an efficient and economic manner to maximize the yield and quality of mulberry. Thank you.